Hi, I'm Gregory Robinette. I work at Mindflow, and today I'm going to show you how to solve complex problems using our technology, the swarm of agents. As an example, we will perform a penetration test fully automatically, thanks to that. The first agent that I'm going to present to you is this one. It's named run command on the server. Prior to this, I have created a server on my AWS account, and thanks to this agent, we're going to use it. So this is how it works. The first step here, run command, uses AWS API to send the command to the server. This one, it's reading the result of the command. Some of the commands that we're going to send to the server will take some time to be executed. That's why it's within a loop and a wait, so we can wait for it to finish, right? So to summarize this very tiny flow here, it's just sending a command to a server, waiting for the command to be over, and fetching the result and sending back the result to the caller. With this agent, we are going to use another one. This will be the pen tester. This one, we can call it the supervisor, for example. This one will be the brain, and it will use the agent we have just seen to perform the actions. So this is how you configure it. First of all, you need to select the model you want to use, right? This is the brain of the LLM. This is the brain of the AI task. So we are going to pick Claude Sonnet 4, but you can see that we are supporting a lot of them. Then you need to provide a mission, an objective. Here I'm just saying that, yeah, you are an expert in pen testing web applications. Your target is, and I provide a server name. Then I'm going to attach to it some agents, the one we have seen together, run command on the server. Thanks to this one, it will be able to run a pen test. So I have set it up this AI task with a brain. I've picked the right LLM I wanted. Then I have described the mission, what I'm expecting, and then I've provided a set of tools. Here, one agent being able to send a command to a Kali Linux server, wait for the response, and return it. Now I can see that it's over. It was very quick for a pen test, I must say. Now I can dig into the logs of execution here, and I can see the result. And, well, I can see the result here, and the LLM is saying that, yeah, he knows what I want, but basically he doesn't have the authorization to perform that. That was expected, of course. Claude is not allowed to do pen testing like this. A workaround to that is to delegate the responsibility on a human, right? So I'm going to build another agent, which is named human in the loop. As you can see, it's also very simple. The first step is send a message to a channel. So the LLM, when the LLM will have a question, it will be able to use this one and send me this question to this Slack channel. As you can see here, the next line is a dotted line. It means that the flow will actually stop, the agent will stop here until the response is received. So, yeah, let's link that to my supervisor, human in the loop. I'm going to update the prompt. I'm going to tell it ask for permission if needed, as simple as that. And I'm going to hit play again. We're going through the same process, but this time, hopefully, it will decide to call me to ask me if it has the right to do it. So you can see that the flow is triggered here. It actually stopped here, sends a message to a channel. You can see that it's waiting we can see that the supervisor is also running and waiting. And if I go to my Slack channel here, I can see the question. Do you have explicit written authorizations from the owner of the server? I can hit yes. If I go back here, I can see that the flow starts again because the callback is received. I updated the message in Slack just to save my answer here. And now the pen test should actually start, right? So it's going to use this run a command on a server tool to perform actions. And then here, as before, I can go to the logs and see what kind of command has been executed. Here I can see an nmap command run, and I can see that it's triggering another command, which of course will be something different, nslookup, and so on. So the LLM will craft a strategy of pen testing. The first command, run it, see the result, depending on the result, craft a second command, and so on. So it will loop and continue hammering the server until the end, and I haven't specified any stop condition, so it's going to continue and continue. There is a timeout on my main flow, so it will not run more than 5 minutes, but anyway, of course I can change this timeout. Here I'm going to stop it because I'm quite happy with what I've seen. And the thing is that it's not super friendly. I need to dig into the logs to see what's happening, so I want to enhance that a bit. So I've shown you how you can plug agents into it. So as a reminder, agents are like flow. They could be complex or simple, like I've shown you before. But if you want something more direct, you have the tools. And here I'm going to do that. I'm going to search for Slack, the service Slack here. And within this service, if I click on it, I can see all the operations that are available to me. In my case, I know exactly what I want, so it's very easy. I'm going to do post message here, and I'm going to tick this one. But here, of course, depending on your needs, you can select a lot of operation if you want. The LLM will pick the right one. I also need to provide a credential, so I give the right to my LLM to use Slack. And something cool also, I can specify more information in the description of this tool. So when the LLM will use this tool, it will have extra description. And here I'm going to state that, well, use the channel laboratory, and you must use block kit syntax. So the channel laboratory, that's the one I was using before. And block kit syntax, if I don't specify that, the LLM will generate a markdown message, and that's not a big issue, but Slack prefers block kit syntax. Anyhow, that's done. I have added a tool. I need to update my prompt to ask it to do a bit more than before. And just with this sentence, each time you run a command on the server, send a message with the command, the goal, and the result. Right? That should be enough for me to follow the process. I can restart it, of course, and it should follow the same path. So I should receive a request for authorization here. Here it comes. I click on yes. Human in the loop gets finished. And then here it will trigger this again. And it will start with the nmap here. Maybe the second command. Yeah, another nmap. This one is actually going to take some time. Yeah, it will take 30 seconds, so I'm going to jump 30 seconds ahead in the video. Okay, so now he has finished his second nmap. And hopefully it will send me a message. Here we go. And here I can see penetration test initial recognition. the command, the goal, initial port scanning and service enumeration, the targets, the key findings. So he has found an open port on 2280. He has found MySQL running, security concern. So now it's continuing. He will draft a new command and move again, send me again what has been done with the findings and the next step and so on. So it will continue doing so. So I'm going to stop it because we don't need more. So I could enhance that even more, of course. I could add, for example, anytime you find a security issue, just create a new Jira ticket, and that will be as simple as I've done with Slack. So adding one sentence and picking one right tool. Here it will be Atlassian Jira, create a ticket, and so on. So that's it. And I can enhance it like this very easily. So the goal of this demo was to show you how simple it is to use Swarm agents to tackle complex topic, right? And I hope that now you can think of some problems that you have that could be tackled by this kind of technology. Thank you very much for listening, and I hope to see you soon.